if you think about solving a problem with AI, you can think about like, basically you're going to have to try like 50 or 100 things. And, at the end of that, you're going to find something that works. So either you do it sequentially or you do it all at once.
Welcome to UpTech Report. This is our Applied Tech series. UpTech Report is sponsored by Terraleap. Learn how to leverage the power of video at Terraleap.io. Today, I am joined by my guest, William Falcon, who's based in New York. He's the CEO and co-founder at Grid.AI. He's also the creator of PyTorch Lightning. Very excited to have you on, William.
Yeah, thank you for having me, Alex. Very excited to be on.
Now, GridAI, your focus there is enabling companies of all sizes to train, we call state-of-the-art AI models on hundreds of cloud GPUs and CPUs just right from their laptops. But you're also pretty well known in the community around PyTorch Lightning, being the creator of that. Help me understand, like, what's the journey that you've been on here with first starting PyTorch Lightning, the community you created around that, and now with GridAI, the problem that you set out to solve?
When I started doing deep learning research, it was around 2016, I want to say. And, I had been a software engineer for a few years, and I was coming to the AI world, and it was really interesting how there was not a lot of standards, like there weren't best practices, and it's still true today, right? Everyone's still developing their best way of doing something. And it's a new technology. So we're all trying to figure it out, right? I mean, we are as well, right?
It's like a growing field, always changing, yeah.
Yeah, and so what I started doing was I wanted to figure out how to move quickly through research, right? In research, you have a lot of ideas and you need to iterate on those ideas. And that process is not really that different at a company, right? At a company, you have data and you have some hypotheses as to what's going to give you the most value, but you're going to have to try a bunch of them until something does give you a lot of value. So it's the same process, this like iteration process, right? And I realized that I was having to copy code over and over again, and it was really not scalable. And I wasn't focused on scaling, obviously, because I was just doing research. But if you think about solving a problem with AI, you can think about like, basically, you're going to have to try like 50 or 100 things. And at the end of that, you're going to find something that works. So either you do it sequentially or you do it all at once. And some of those things, you're not going to know until you try something. And then that unlocks a different thing, right? So it's kind of this tree of ideas. So I basically wanted to get a lot of this done through Lightning. And so I started working on this kind of internal project for myself, and it was really useful. I put it aside for a few years and then kind of went into the startup world and, started putting deep learning to production. And then when I came back to do my PhD, I was like, let's dust this thing off and let's see if I can take a stab at it again. And yeah, it's taken 3 or 4 years at this point to get that right. But I think we arrived. And I say we because it's really a community project now, and it's over 400 people who are working on it. We arrived at something that helps you move really fast through your research ideas and then put it into production very quickly without doing a lot, right? Because before you had this bridge between the research group and then the production teams, and that would take like 6 months or a year to put anything to production. So Lightning's helped a lot, and Lightning helps you do that process, but it doesn't help you when you're doing it at scale. So Lightning can help scale up your models, but you still have to do a lot of infrastructure work on your own if you want to do that. So when I was at Facebook, all of this is already done for you, a lot of it, right? And so the machines are there and all these different things. So I don't have to worry about it. But I realized that this was a problem that if you're not at Google or Facebook, I don't know how you're going to solve these problems, right?
Like the big companies, yeah, they got the infrastructure, they got the people, but outside of that, we're getting to the point where machine learning, deep learning, there's a lot of opportunity, and it shouldn't be reserved just for the folks that happen to have the giant infrastructure. It should be able to accessible. And it sounds like that was your driving thought and feeling that like, I got to find a way to solve this.
Exactly. I mean, you have to think about it. Like, I didn't start in computer science or deep learning. I started, in the military before. And then when I started research was really neuroscience. So there are a lot of scientists out there, and, these are people like data scientists, right? So at a company, what will happen is you hire data scientists. Most of the time, that person came from a PhD or a master's degree, and they were focused on math or physics or something, not engineering. And now you're telling them to go scale up models, and they're like, that's not my thing, right?
We're getting to the point where the use case of using machine learning, deep learning, those are two separate roles. They don't need to be an expert in infrastructure to be able to run their models, or they shouldn't be.
Exactly. And so this term MLOps came around, right? And so I'm sure you hear it in your company. And I think that, like I've said this before, but I think if we're doing our jobs right, that should just disappear. Like if you use Lightning today, you don't have to worry about a lot. Like you just focus on what you're trying to solve in the data. With Grid, when you merge that with Grid, now you don't really have to worry about infrastructure or how you're going to scale things up or how you're, making sure that your data is not going to bottleneck your training. There are all these nuances and things that we know because we spend a lot of time obsessing over these details. So we know how to get them right, which means that the data scientist, the machine learning engineer, they're left to just kind of focus on the data and the problems that they want to solve. So they don't have to deal with any of this other stuff. So you don't need to go find unicorns for like expert engineers and data scientists and mathematicians and all this. Just get someone who's really good quantitatively, like who can, look at data and really drive a lot of insights and solve that problem. Like this is what humans are best at, right?
Mm-hmm. So PyTorch Lightning, that's really focused around the framework so that it can run well. But for those that need help with the infrastructure, that's where your focus of Grid AI is, that they can just scale up, turn on, and or as your website states, to be able to train on hundreds of cloud GPUs and CPUs right from their laptop. So just simplifying that process.
Yeah, exactly. And this is something that I think a lot of people are not used to today, right? They like don't have this. It's interesting because the world of machine learning and deep learning, like they're not really using these resources as much as they should or know how to. It's because it's really hard, right? So before PyTorch Lightning, people like even within Facebook, like we had some groups who would train things on like 32, 64 GPUs, and like they were very specialized at that. That ability is now democratized through Lightning. So you can just do that and you don't have to be an expert. So it's the same thing for GridAI, right? Is you don't no longer need to care about the cluster or care about your MLOps or any of the stuff. If you want it, it's there and you can access it, but you don't need to worry about it, right? If you just need to spin up 20 models each on 32 GPUs, you can do that. If you need high access data, you can do that.
You mentioned that if they want to, they can. So it's still kind of an open framework, so they can look at it, or is it just kind of closed? Like how is that?
Well, we're building things for professionals, right? And something that separates Lightning from the other frameworks is that it makes it very simple. Like the API and the way that you interact with it is very, very simple. But if you're an expert user and you need a lot of control, you can always get it, right? So it's not a black box. It's not a kind of these AutoML things where like, you don't know what's going on. Right. You could actually have a lot of full control. And that's what GridAI is about as well. That's a philosophy that we bring. It's if you don't want the control, don't worry about it. But if you do want it, you can get it.
Now you guys have been around just over a year. So it's like a lot of it happening for GridAI, though it's been two years from PyTorch Lightning when that began, right? Roughly.
Correct. Yeah. And I think, the majority of people on the team have been working on deep learning or AI related things for at least 4 or 5 years, maybe longer, some people. So we've all, been doing things. We've all been doing this in other lives as well.
It's like all culminating, and now it's like be able to move forward. What can you speak to as far as so far the use cases and folks that are on there, the types of organizations and businesses that can use it and should be using it?
Yeah, it really ranges. And I do want to say that, Grid is not just for Lightning. You can use other frameworks, right? So it's not wedded. You get a much better experience if you use Lightning, but you can use things like TensorFlow and PyTorch and so on. So we're not restricting that. And I say that because the use cases are very broad, right? So we're seeing e-commerce, we're seeing gas and oil, we're seeing like healthcare, finance. And it's interesting because the Lightning community is huge, right? I mean, there are, I don't know, easily 50,000 people across the world using Lightning, thousands of companies. And so these are just people kind of coming in and saying, hey, like, I like how you're solving this problem. So can we, if you can do the same for MLOps, please go for it, right? So, what's important about Grid is that there are many ways that you can deploy the platform. So if you care about data privacy and everything else, then obviously there are the uptime deployments. We can orchestrate things in your own VPC. So we're very cautious about that, right? I mean, I came from finance. I worked in healthcare for a bit, so like I understand all these nuances as well. And if you don't, like, I mean, Grid never looks at data or anything like that. But there's a way where you can basically have us coordinate it for you, like all the infrastructure. You still leave metadata coming out of the clusters, but it's just about what machines are running and what's down, but nothing ever about code or data. So it is very, very secure. So HIPAA and all of these finance things that you need to do, As long as you can do it on your own cluster or on-prem, like we handle that.
Now, you actually had some experience yourself training models, if I understand it correctly, around something about COVID, AI and COVID. Can you share about that?
Yeah, so I actively do research at NYU with my advisors, and when COVID came out, we had this idea to figure out if we could basically take models and have people like basically call in and then cough or speak, and if we could take basically record them, right, and then take their sound waves and try to figure out if we could detect if they had COVID, right? And so
Just from
there are
their
a lot of
cough.
issues. Yeah, so it's an experiment, right? And so we collected data. Basically, we built a system where people would call in, and then we actually ended up collecting a lot of data. And what ended up happening was that we wanted to use models for that. Now, there are a lot of, we were able to detect hints of, hey, you're sick or you do have something, but it wasn't foolproof. And there are, I mean, with medicine specifically, there are a lot of issues. And so I'm a little bit skeptical now that you can do this. And there are like actual tech limitations for it. For example, we found that, your phone records things in certain bandwidths, right? So in the higher pitches may be dropped by the signal, by the cell carrier. And that's where you could register some of these like, wheezing noises and so on. So it's not 100% foolproof. I think if we can dig into it, maybe we can get somewhere. But yeah, that was a really interesting experiment. Yeah, so
There's so much opportunity, but it's so much of an experimentation and exploring, which is I guess the main reason why you've built this platform is there just needs to be more. There needs to be more opportunity, more exploring, more testing simultaneously, and not waiting forever to one run and then run another one. But
right.
there's a lot of hype around AI and what it's capable of.
Yeah.
And people can seem to say, well, AI is going to solve everything and it's easy and you're just done and you're good. Well, what do you say to that?
Yeah, it's a lot of hype for sure. I mean, so I'm a researcher, right? So I live and breathe the academic side, the papers, and I know where we're headed. And a lot of these things work on very small data sets, and when you take them to the real world, they don't scale, right? That's not to say that they don't work well in certain cases. Basically, like if there's anything where it's like a natural signal, so like speech or images or videos or text, AI will do much better than kind of more traditional methods, right? And it's just a little bit more nuanced the way that it can kind of interpret that information and extract features from it. But I think that what happens then is the media or other companies take that and then they just like extrapolate it of what it can do, and then they'll show you one specific example where it works really well, but that's the tip of the iceberg, and then you see around that and it doesn't work. And so I think what burns companies really is they'll buy the hype and then they'll go build a model, and then it'll work on like their dummy data set or something small, and then they put it into production and then they get in trouble, right? So that's yeah.
So what would you then, as a true data scientist and research yourself, but you're providing a platform for more people to do testing, what would you be saying to business leaders where they're seeing the hype, but there's still truth underneath the hype, right? There's still truth there. So what would you want to say to a business leader who's saying, well, we want to use it, but how do we balance and not create too much hype around it?
I think just temper expectations, right? I think it's good to start with something simple and then build up, right? You don't have to use deep learning. So when we talk about AI, we're talking about mostly deep learning right now, right? But there are other models you can use that, if you get into the math, they could be considered deep learning or not, doesn't matter. But just get into something basic, baseline that, and then go from there, right? Don't jump into the most complicated model. So I think it's you can de-risk a lot of the hype by doing that process. What is interesting about Lightning and Grid and the community is that we're all at the heart of this. So what is really helpful for everyone is that we actually can help in that way, right? Like you can join our Slack group, you can join our conversations, and like we will actually, gut check you and be like, that's not going to work. And Lightning and Grid are built around a lot of these best practices to keep you from making mistakes, right? Like I see people coming up and saying, okay, I want to, there's something called spot instances on Amazon where you can get like, 90% discount on your compute, which is great. And we use that a lot at Grid. But if you start training on multi-nodes, for example, you could actually throw off the model, but it's subtle because it's how kind of the models learn and the gradients update. So it's very like mathy, I guess, if you start to think about it. So we try to just kind of call it out, and we're like, look, we were not going to enable certain functionality because we know it's bad for you, right? And so we block that off, and the same for Lightning. So it's not just about structure or speed, it's also about giving you kind of best practices embedded, and it's from hundreds of people across the world who are experts at this, right? Who are all the top companies. So our knowledge is getting embedded in there. So as a company now, you don't need the expert researchers. You just need people who understand the problem really well, and then they can leverage our technology and our collective expertise to kind of do a much better job.
And I apologize if I'm not perceiving this properly, but it kind of sounds like we're getting to an age where you can build websites in HTML, and you don't really need someone who's an amazing developer, knows all a bunch of code. They can just create a website because all the content's there. We're getting to that space now with ML and deep learning, because the algorithms that are already proven and in different places, as long as you know which ones to use in the community around there, you can search for finding answers. You don't need a really deep research to build new algorithms or anything. Am I getting that correct?
Yeah, I think of cars. Like basically think about, we just invented the car, AI, right? And for the first few years, every single person was either building their own car or like learning about physics and engine mechanics before they drove a car. You know, like today, you don't need to, no one needs to know this. You just like buy a car, you use it, right? And the car manufacturers are going to embed all the best things in there. So you're not going to be able to go like 2,000 miles an hour, 300, whatever it is, something unsafe. You're not going to be able to do turns at crazy speeds. So they're going to build in a lot of these safety mechanisms as well to keep you from making mistakes. So it's a lot of what we're doing as well. The difference though is that in AI, sometimes you do need to be an expert to dig into something. So we'll give you an escape hatch basically to say, okay, well, like a car mechanic, that's fine. Take it to the mechanic and they'll know exactly how to look in the engine.
A machine learning mechanic. I love that, car mechanic too. Hey,
Yeah,
my model's not working. Can you take a look? The wheel's coming off. It's giving me
right.
some more data.
But that's how you scale it up, right? Like not everyone in the world can be a car mechanic. Like people just need to be able to drive it and use it. And then when they really need something special, then they can take it to those people. And that's the community. That's the Lightning community. That's the research community that you can tap into when you need it. But it also means you don't have to hire experts, because there are amazing people out there who are coming from biology, who are coming from chemistry, who are physicists, political scientists, who know the math, who know the research process, who know how to solve problems, but they're not expert engineers, and they don't need to be like deep learning experts either, right?
Mm. So for a business leader to say, there's just so much energy, we're going to be left behind. We need to really embed and have more opportunity for running different new machine learning algorithms, deep learning algorithms.
You're also not going to you're not going to compete with like the big companies though. Like think about it, like hiring, good luck hiring against Facebook or Google for AI talent, right? Like a lot of the top, PhD students and researchers that are coming out are going to these places because that's, they're getting those options. And so they're kind of sucking that talent dry, but it doesn't mean that you shouldn't have access to it.
So what's the typical role then, or title of someone that can be running these algorithms and could be using a platform like Grid?
So data scientist, machine learning engineer, research scientist. I think people call these so many different names, but I guess I'll just say if you have data and you want to use a deep learning model or machine learning models to get value out of that, then this is what you use.
What would you say is for all those different roles or titles that you just gave? What qualities do they have, or either someone who's wanting to play that role, something they should be building themselves, or a business leader that's trying to hire someone to be able to run one of these? What makes up a good person like this?
I think at the end of the day, it's having a strong quantitative background to be able to, speak intelligently about data, about insights, and about some of the math. I mean, in industry, you're not getting so deep into the math. In finance, you might be. In research, you for sure are. You spend a lot of your time in the math. But in industry, you're just kind of at the high level. So it's really someone who can understand it at a high level and kind of reason through it, right? I think that the word data scientist is very abused in the world, right? So there are people who are they're data scientists who spend most of their time on business insights, like what's my churn, what are my users doing, that kind of stuff. For that, you don't really need AI. I mean, you can use models to help you, but your job is more analytics, right? Your analysis. So it's this like Grid, it's less for those people. There are certain data scientists who are then sitting there and modeling, and they're maybe building recommender systems. Maybe they're building maybe some of the models that the analysts will use to do something, right? So in finance, it might be stock prediction, it might be, demand prediction. I mean, you can, everything that, I think anything that has a bunch of rules can be kind of rewritten with AI, right? So if this, then that, then that. So predicting, like fuel loads for planes, I mean, you name it, right? It's basically how creative you can get. So that's what Grid is focused on, right? Now that's a problem solving phase. And then today there are machine learning engineers or research engineers who sit there and like optimize models to work in near real time, right? So if you're, for example, at a news agency and you're getting recommendations, they have an interesting problem because a story will break now and they have to retrain a model within a few seconds and then give you a recommendation for the new stories because there's a time element to it, right? Whereas Netflix doesn't have that problem because movies come out, they can retrain models for days and then it's fine, right? So there you need to be really good at engineering. And so that's really where Grid can help you do that. And if you're like working with Grid and Lightning, then we're going to give you basically the state of the art on how you can train the fastest, the quickest, and get those solutions fast. So, and then there's the other side. I think maybe some banks will have this like more researchers. So like Facebook and Google have research scientists, and these people are sometimes academic focused. They're literally just publishing papers. In banks, it'll be like analysts who are publishing reports about companies, and there'll be people who are doing this for finance as well. I remember like Barclays had a strong group about this. They were like doing research into how do you do certain trading strategies and so on. And then there are like the other kind of researchers who are more applied. So they're taking the papers that are being published and trying to figure out how to apply them to what they're doing, right? So you could take a paper for speech generation or let's say speech detection and use it for finance because it's just a time series at the end of the day.
Got it. So if I come back and try to recap again, the folks that best can use the platform are researchers, engineers, developers of AI and ML space. That's, if I got that correct, is the best ones that could use the platform.
Correct. Yeah. And hopefully, the longer that we continue to build what we're doing and execute on our vision, the less of an expert you'll have to be.
Again, I love the analogy of the car concept. Is like eventually anyone will be able to run it because you built the safeguards in there, and then when you need a mechanic, you can run to them.
Exactly.
The roadmap of where you guys are headed. Anything you can share of features that are going to be added or something exciting that you guys are working on that you can feel comfortable sharing here?
Yeah, of course. I mean, yeah, we know the space really well. We know the problems that happened, from training to inference to post-inference to production to all the challenges in between, right? I mean, we have people who've done this for many years. So we're well aware of the challenges. If we're not tackling them right now, it's because we want to get one part right, and then we'll kind of move into the other areas, right? But I think what's important is that, I don't know, I see there are a lot of companies out there that are focused on machine learning and AI and, a lot of amazing platforms. And I really think that the problems are so hard that, we're all going to have to collaborate at some point. So actually, my take is really like, I want to make sure that we're bringing in the best in class around to all work together towards solving this, right? Because it is a massive problem that can help a lot of people if we can figure it out. So today we're focused on training, right? How do we scale up your training? There's also how do we help you do production and inference much faster, right? So that's kind of the next phase where we're starting to get into as well. And that's Lightning as well. So Lightning for the first year was focused on how do we make it really easy for researchers and creators to build fast. And now we're focused on, for last year, really, well, since September, I guess, we've been focused on, okay, now you created, how do we bring that into production as fast as possible and scalable? And so you don't have to worry about it, right? I actually think that all of the production stuff, it can be automated, right? I think that the research process is the part that can't. Like, this is where humans come in and this is what they're best at, right? Creating ideas and going through that. But we've been deploying things forever. Like we've been, how long have we been deploying websites for? Like 10, 20 years at this point. So it's not much harder. You just need to know a little bit more about machine learning. So if we do our jobs right, like you shouldn't have to worry about that stuff.
People can focus on where people are best utilized, and automation technology can run the best, can run the rest. For those out there, whether the researchers, engineers, or developers in AI and machine learning, Are there any resources that you would recommend for continuing growing and learning themselves of what they're trying to grow in, whether it's books or podcasts or places that you read, sites, anything that you would recommend?
Yeah, so there are a few classes. I mean, if you're getting into deep learning, I think Karpathy's class, I mean, it's a very popular class from Stanford. It's a really good one. I don't remember the name of it, but it's free on YouTube. So one of my advisors, Jan, he took this deep learning class at NYU with Alfredo as well. So it's actually, I think, the first year that's been made publicly available. And he's one of the creators of deep learning and founders. So it's really cool to see how he thinks about stuff. So I would check that class out as well. And then I do think that there are a few Coursera classes that are interesting, but I would also work on the books, right? So there's, depends how mathy you want to get. I think the deep learning book is a good start by Yoshua Bengio and Aaron Corville and Ian Goodfellow. So that's a great place. And then, how deep you want to get into the journey. I think there's, Kevin Murphy's book, machine learning as well. And what are other good resources? I mean, we have a lot of tutorials as well. So we do a lot of teaching. The documentation in Lightning specifically teaches a lot of these concepts anyways. And through Grid, we do a lot of these tutorials. So I think we are very focused on helping people, 10x their skill set. And so something that I'm personally passionate about, because I've been a data scientist and I've been a researcher and I've done these things, is I don't ever want to replace these folks, because I think that my goal is really to empower them. So and we see this today with Lightning, and we'll see this with Grid, is I want to make people 10x better, right? So if you're a data scientist or machine learning engineer, using the stuff that we're building is going to kind of help you become much better at your job, right? So I think that where we're going to crush it as humanity is where you can take, people who are brilliant and augment them with machine learning or these tools and let them do their jobs better, right? I'm not a big fan of these kind of AutoML black box things, because they remove what humans are best at, and solving problems is not just a function of looping over data and then getting the best results. It's more to it than that.
I appreciate your distinction of where humans play best a role here. I want to kind of close here on a question of just looking ahead. Tech predictions that you would make in the near term. What do you see happening in the next year or two and longer, a little bit 5-10 years from now?
So a few years ago, we had kind of BERT was a big model in deep learning, and that introduced transformers, this type of neural network. And then you saw OpenAI and GPT-2, GPT-3, and so on. And under the hood for BERT and transformer, you have this kind of ability to learn without labels, where it blocks parts of a sentence out and then uses that as a training signal. And a lot of what I've been researching over the last few years, and kind of what a lot of the lab at NYU and Facebook are focused on, is something called self-supervised learning. And obviously, I'm doing that research because I think it's interesting, but I think it's also probably the most promising today, because that's going to enable a lot of different modalities. So computer vision, images, videos, those kind of things, to work without labels, right? And so I think the golden thing that will happen over the next few years is that we'll be able to train models without having to label the data. Now, I'm not saying you won't have to label some of it, but it won't be the huge efforts that we have today. And you're already seeing the proof of that in the GPT models and the transformer models, right? So now think about how that, what will happen when we bring that into computer vision, audio, videos, and so on. So I think that'll be probably the biggest change for companies and for everyone out there. And it also means that you'll need fewer data annotation. You'll be able to spend more time on just getting more data, and then it'll tap into data that you may not be using today because it's not labeled, right? So that's one. And then I guess outside of AI, I mean, I think, I don't know. I always love fintech, so I think there's going to be. I like Bitcoin and crypto and all these things. I think we need to do a lot of work there on making sure that we're not damaging systems and platforms with miners. So we've seen this. GitHub has seen this. A lot of other companies where miners exploit your compute to basically do something. So they're kind of making a lot of the free offerings out there, painful for people to support. So I think crypto, if we can find a way to make it a little bit more, I don't know, less resource intensive, that'll be super helpful.
Now making that happen, that's that's a whole nother thing, but that's ideally the direction. I appreciate the future that you're painting, William, and the platform that you guys have built to help with research itself, in some ways, democratizing it. So even though you don't have to be the big giant tech giants to be able to run more algorithms. Thank you
Exactly.
so much, William, for your time. For those that want to learn more, you can go over to Grid.AI, and it looks like you have an individual level with the free credits, right? A free tier, and then a next tier in the enterprise tier. Is that how you guys work?
Yeah, so you can come on the free tier, and there you're basically going to get some credits, and then that's really meant for you to go wild and do what you want to do there. That for us, we're not making money on that tier. We just want you to try the platform and do what you need to do. And yeah, so please check it out for sure.
And get started. Thank you again so much, William. And everyone, go to uptechreport.com again to see this full interview and a lot more. And we'll see you on the next episode at uptechreport.com. Have you seen a company using AI, machine learning, or other technology to transform the way we live, work, and do business? Go to uptechreport.com and let us know.